And now that we have our class ready to be used, well, let's use it. So here, what I'm going to do, I'm going to replace that with the functionalities of the class. And the first thing I need to do is actually to create an object. So when you have a class, this class is just, well, this is just a structure, okay? This doesn't do anything by itself. What you need to do is to create an object, which is an instance of the class, and then you can use the class. So to create an object, it's very simple. First, you put the name of the class, so LED, and then the name of the object you want, which can be anything. I'm just going to call it LED with lowercase. And then, so if you are going to use the default constructor, which is no parameter, in that case, you just put a semicolon. And that's it. The default constructor will be called. Now, if you want to use another constructor, actually we want to use that one, then you add some parentheses and then you provide the parameters here. So we need to provide the pin number and we have a defined LED pin. So let's actually use that define right here. So this line, what it will do, it will call the constructor here. So we provide an LED pin, which is a byte. It will call the LED here constructor and assign the pin number we give, okay, to the pin here, the private attribute from the class. And note that here I have created the object in the global scope. Okay, so that's what we are going to do here in this course. We are going to create objects here in the global scope so we can use them in the setup and in the loop function. So now that we have our object, well, we need to use here, I'm going to replace this with led.init. So as you can see here, there is no more pin mode, etc. The pin mode is inside the class. So I could use init or init with default state. I just use the normal init. One thing that you may want to do is to actually do the init inside the constructor, but this is not really recommended because, well, when you create here a variable with the constructor, you don't necessarily know which order the constructor is going to be called, when exactly. So it's better to initialize hardware components in the setup. So like we did before with the pin mode, here we just call the LED init inside the void setup of the Arduino program. And now in the void loop function, what we want to do is not digital write LED pin high, we just want to do led.on and then led.off. So yeah, as you can see, to call a method from an object, you just add dot. Object.method. And the method should of course be public. If it is private, you will get an error because you can't call a private attribute or a private method. Here, all the methods we have created are public, so we can call them from the code here directly when we create an object. And well, you can see that this code here, when you look at this, just this is much more clear and you have much more context and much more abstraction. Here it is very clear that we create an object, so an LED, we provide a pin number of course, and then we initialize the LED and then we power on the LED. So we wait with a delay here and we power off the LED. This makes much more sense than writing digital write, because what does digital write means? Digital write means that you are going to use some hardware functionalities from the Arduino to write some value, some digital value to a digital pin. It doesn't mean you are going to power on an LED, okay? So with this, we have much more context. And as you can see, all the Arduino functionalities here are inside the LED class. So basically, it's like they are hidden. So when you just see the main program, you don't see the hardware functionalities, you just see the context and the abstractions that you use. And well, for now, as you can see, the code is, well, much more bigger than the code to just make an LED blink. But this is just because this is the setup for the project. And later on, just after that, we are going to see how you can better organize your code so you can reduce the main code. And then when we are going to add more functionalities, more classes, etc., you will see the true power of object-oriented programming. And your code, instead of just getting bigger and bigger and bigger, will get much more organized, scalable, modular, readable, etc. And one last thing here is when you actually create an object, well, you can directly create an object like this, or you could try to use dynamic allocation with the new keyword, for example, and the delete keyword, but that's not really recommended in Arduino because, well, Arduino is quite limited, and if you have a small program like this, well, you don't need dynamic allocation. And if you have a more complex program, maybe using dynamic allocations, you will have problems with the memory and, well, you are going to mess things up. So I recommend using this way to create objects, which is to directly call the class object constructor with the parameters in the global scope. And well, actually what we can do, of course, is to, so let's compile the code. Let's name it LED OOP. Okay, so it's done compiling, and then we can upload the code. So make sure you have correctly set the board and the port right on tools, and we can upload the code to the Arduino. And you can see here the built-in LED, so the LED with the pin number 13 that we are using is actually blinking every 500 milliseconds. So, well, the functionality here is working correctly. And congratulations, because you have written your first class with Arduino.